Hello, today's topic is graphing linear inequalities. The materials you'll need today: a straight edge graphing tool, ID card or a ruler, and a pencil. If you need an essential question, how can I graph a linear inequality? Know what type of line to draw, and know where to shade the graph. Hopefully by the end of this video, you will have a much better understanding of how to do all three of those things. So let's get started. I want to start off by talking about the prior knowledge that we've had with inequality signs. Before, we've had inequality signs like this one, which is greater than, and this one, which is less than. And we've seen it in an example like this: x is less than 3. And when we solved it, we were able to graph it on a number line like this, where we had an open circle, and then we drew an arrow. And the arrow in this case would head to the left, and that showed our solution set of everything to the left. Moving into linear inequalities, which is what we're going to do, we're going to be on a coordinate plane, just like linear equations, and we're going to draw a line. In this case, with the greater than or less than, just like we had our open circle here, we're going to have a dashed line, and we're going to talk more about that in a minute. And this line right here, I'm going to call the boundary line of our inequality. And we're going to talk about a boundary line. And the boundary line, the points that are on this boundary line are not solutions. So when you have the dotted line, the points are not solutions, just like when we went back here and we had our open circle, that 3 in this case would not be part of the solution set. A lot of words put in there, but I just want you to try to pull on that if you recall. We also had the inequality signs greater than or equal to or less than or equal to. So x is greater than or equal to 3. We were able to put it on the number line, but in this case, it was a colored in circle, and our arrow was heading to the right, showing that everything greater than 3, but including 3, was part of the solution. With our linear inequalities, we're going to have a line, but in this case, our line is going to be a solid line. So we have dotted lines or solid lines. And in this case, the boundary line, just like up here where 3 was included in the solution set, all points on this line are going to be solutions. The other thing that we're going to talk about is we're going to have to be required to shade. So you will need to shade the graph for linear inequalities. You will need to use test points to determine which side of the line to shade. And let's talk about what a test point is. A test point is any point that you select to figure out where shading needs to occur. A test point cannot be on the graphed line. And best practices say to select one point above the line and a second point below the line. So if we go back here to this image, I would want to pick a point above the line here, and then a second point below the line here, set of coordinates, and then we'll show you how to do that. If you need to pause this or watch this back, I know that was a lot of information, and we're going to get into 6 examples in a second. So here we go. Here's our first example. So our inequality, y is greater than 1/2 x minus 4. My m, or the slope, is 1/2. The b is 0, -4. And we noticed from the previous slide that when we have greater than, our line is going to be a dotted line. So let's graph the line first. We start at 0, -4, and then we go up 1, right 2, make another point, up 1, right 2, make another point, and then we're going to draw our dotted line. And now we're going to figure out how to shade. And this is the big part between graphing lines and graphing inequalities. The best test point to pick is always 0, 0, because it's easy mathematically. We take the 0 for our x and substitute it into our original equation there. We pick the 0 for our y and substitute it into the original equation there. And then we're going to simplify to see if this point, 0, 0, is a solution. So can't simplify the left, but we can on the right. 0 times 1/2 would be 0. So 0 -4 is -4. So the question, is 0 greater than -4? Yes, it is. So therefore, what that says, since this is a true statement, is that 0, 0 is a solution to this inequality. Well, 0, 0 is here. It is on the top side of the line. So 0, 0 and every other point on the top side of the line is a possible solution. You could pick any set of coordinates up here and you would get a true statement. So what you do in order to show that is you shade the graph. Now, if you notice these little white pieces down here, they should be shaded as well. It's just that PowerPoint doesn't allow me to partially shade boxes. So I did the best job I could. Why don't you pause that and watch that back if you need to write it down. And let's move on to our second example. Our second example says graph the inequality y is greater than or equal to 2x plus 1. So my m is 2 over 1. My b is 0, 1. And the line for this one, we're looking at the inequality sign, says greater than or equal to. If you look back above on your paper, you would know that you have a solid line. So let's graph it. We go over here to 0, 1, and then we go up to right 1, make a dot, come down to left 1, make another dot, and make another dot here. And now we're going to draw a solid line through there. And the test point we're going to pick again, 0, 0, my favorite, which is right here. And we're going to figure out if this is a solution. So we take 0, 0 and substitute it into the original equation. So 0 for y and 0 for x. 2 times 0 is 0, and 0 plus 1 would be 1. Is 0 greater than or equal to 1? And the answer to that question is no, it's not. So therefore, this point 0, 0 is not a solution. What you would want to do now is you would want to pick a point up here, maybe on the y-axis, and prove that point is a solution, just to confirm. But what happens is when this is not a solution, that means no points on this side of the line are, and every point on the other side of the line are, so we shade the other side of the line. Once again, the PowerPoint doesn't allow me to shade partial boxes, so please make sure that your shading goes right up to the line. Okay, here's your third example. And I am going to have you pause the computer and give it a shot. Fill in your M, fill in your B, figure out the line. And here we go. My M is -1/2. My B is 0, 0. My line, looking at the inequality sign, is going to be dotted. So when I graph this, I start at the origin. I go down 1, right 2, make my point. Down 1, right 2, make another point. And I can go in the other direction. Up 1, left 2, and up 1, left 2. And then I draw my dotted line. And now I need to figure out where to shade. Well, I can't use the origin because it is on the graphed line. So I need to pick another point. So I'm going to pick 0, 1. When I substitute that in to my inequality, I get 1 is less than or equal to 0. This is not a true statement. So the point 0, 1, not going to be shaded. So everything above the line, not shaded. Everything below the line is going to be shaded. For the last one, I want you to give it a shot. Here's your inequality. Y is greater than or equal to -3x plus 1. If you want to use 2 test points, you could do 0, 0 and 0, 2. If you only want to do 1, that's fine as well. And then answer the question at the bottom, is there a relationship between the inequality signs used and the area that is shaded? And then we'll go over that in class tomorrow. Good luck, and I hope this was helpful. If you need to go back and watch it again, by all means, do that as many times as you need to. Have a good day.